Hello, students. Today's lesson is on work done and gravitational potential energy. The question is, why these two topics together? Mostly when you are in secondary school, you'll be taught gravitational potential energy and kinetic energy. Yes, that is correct. But it's very useful to know what work done. And then through work done, you'll be able to understand why the formula for gravitational potential energy, it makes more sense. So that's why this video focuses on these two. It focuses on what work done is, and also what type of work when you do, you generate gravitational potential energy. So first of all, I would like you to think about describing the energy changes that takes place in a car. Pause a minute and reflect. A car. So first of all, from our previous lesson, we realized that a car is an energy device. It's an energy converter, actually. It converts energy from one form to another form. So what energy goes into the car to make it work? Right. So assuming this is our car. Okay. Assuming this is our car. Right. What energy goes into the car to make it work? So you got to put in some form of energy, and then the car can use either electricity when it is electric car. Guess what? If it's not electric car, what energy will be the input energy? The energy that you need to put in to make it work. If it's not electrical, then it's going to be chemical. Why chemical? Because the fuel has chemical energy. The fuel that you put into cars, they store chemical energy. Okay? So you remember from previous lessons, we said that every energy store in the form of fuel, food, or nuclear, they are stores of energy. So for food and fuel is chemical energy. So the chemical energy is from the fuel. Okay. So now what energy comes out when the car does some work? So once you put in the fuel, now the car has to do some work. Okay. So the car has to work. So when the car works, it's basically changing energy from one form to another form. That's how cars work. So when the car works, then you're gonna get different forms of energy coming out. And this is what we call the output energies. Okay, it's the output energy. The energy that you put in is input energy. And from the law of conservation of energy, the output energies should be equal to the input energy. They have to be equal because energy is neither created nor be destroyed. Okay, so the output energies, we have a few of them, which we can have a look. Can you guess which energies will come out? The car is in the motion, right? So any object in motion, what sort of energy is stored in there? Is coming out. If the object is in motion, what sort of energy is coming out? The first energy is kinetic energy. Okay. The car makes noise. In fact, the noise of cars, some people buy some cars because of the noise. The sort of noise that it makes. For example, Ferrari makes some deep noise. So people like it. Okay. Other cars can make, even some people change the exhaust of the car and make sure that it makes deep noise. So sound is another type of energy that comes out when a car is working. When a car works, it can produce sound. Right, if you're in the car and it's cold, winter, where do you get your heat from? From the engine. So heat energy. Get heat energy. When it's dark and the car switch on the lights, what sort of energy comes out? You get light energy. Okay, so these are the energies that comes out of a car when the car does some work. If the car doesn't do any work, it means there is neither fuel or electricity. So there's neither electrical energy or chemical energy. Then the car cannot work. Does that make sense? Brilliant. So these ones are the input energies. The one that makes the car do some work. The energy that makes the car do some work is called input energy. Okay, so for every machine or for every energy converter or energy device, it has to work. And the work done is basically the energy transferred. Okay, so if you look at the output energy in the example on your screen, you realize that the output energies are kinetic energy, sound energy, heat energy, and light energy. Good. Now, how is work done and GPE related? And that's what we're going to find out soon. Okay, we're going to find out how work done and GPE are related. Brilliant. So move on to the next slide. Doing work. When you push or pull something, it moves. When it moves, you do work. So what does that mean? If it doesn't move, no work is done. So what's the most important thing that you have to think of when you want to do some work? If you want to do some work, you need to think about a force, because it is the force that makes work to be done. You need a force, but you need good amount of force that will be able to move the object over a distance. So when a force acts upon an object, it causes the object to displace. And when the object displaces because of the force applied, we say work has been done. So if you lift a table and the table is not able to lift up, you haven't done any work because the table hasn't moved. If you push something and the thing is still stationary, you haven't done any work. So for work to be done, the force should be able to move the object over a distance. And that distance in one direction is called displacement. Okay, distance or displacement, they're the same, but one of them is a scalar quantity, the other one is a vector quantity. Okay, so for work to be done, the force should be able to move the object over a distance. Actually, for work done is a scalar quantity because it doesn't matter which direction the force is moving and making the object move. The object can move in different directions, basically. So because of that, work done is a scalar quantity. However, a force is a vector quantity. All right. So work done is also measured in joules. Why? Because work done is the same as energy transferred. What's the unit of energy from our previous lesson? Is joules. Is joules. So work done measured in joules is equal to force measured in newtons, and then displacement in meters. Okay, that is work done. But work could be done differently. Okay, but there's one type of work done that is very important that we're going to talk about. So before we talk about that, let's do some few calculations. Now we know that work done is equal to force times distance. Let's look at this question. The red bird pushes the wooden block 3 meters with a force of 4 newtons. What is the work done? We know that work done is the force, 4 newtons, times the distance, 3 meters. So you get 12 joules. Easy, isn't it? Sometimes they might give you the distance in centimeters. If the distance is in centimeters, you change it into meters. How many centimeters make 1 meter? It is 100. Okay, 100 centimeters make 1 meter. So if they give you 200 centimeters, you divide it by 100, you get 2 meters. If they give you 20 centimeters, you do 20 divided by 100, you get 0.2 meters. So always remember that the distance have to be in meters. All right. Also, the force have to be in newtons. So if they give you kilonewtons, then you got to change it into newtons. So 1 kilonewton is 1,000 newtons. Okay, so remember that. Right, let's move on. So these are questions that you could try. Remember, see, look at question number 1. They give you 15 centimeters, so you've got to change it into meters. Okay, question number 2, they've given you the force, they've given you the work done, so you need to work out the distance. So easy, you got to divide. Okay, do this on your own. I'm not going to solve this for you. Question number 3, they've given you the energy and then they give you the distance. So you've got to, or displacement. So you've got to find the force. So you have to divide. Okay, easy peasy. Or we could have a formula triangle from the formula above. We have a formula triangle where you have the force. Okay, so this is our formula triangle. So force times distance, and then work done is here. Work done. So if you want to find the force, you cover this one. So when you cover the force or you circle the force, what are you left with? Work done divided by distance. So which means a force is equal to work done divided by distance. Nowadays in GCSE, they don't expect you to use formula triangles. They see it's been taught to be a basic way, but sometimes it helps you to check whether you've done the arrangement correctly. Also, if you want to find the distance, okay, you cover this one, and then you are left with work done divided by force. So distance is work done divided by force. Okay, very easy. So remember, if it's in centimeters, you change it into meters. If it's in kilojoules, you change it into joules. Okay, so this work could be done easily using these formulas that have really helped you to solve. So now we're going to move on. Okay, these are the answers. You can check it and then you mark your work. Easy. So this is an experiment to measure work done. Okay, you have a Newton meter, you have a rubber band, you have a box. So you need to work out how much force that you put in and how much you need to apply the force, and then wait and see how much the distance that the object moves, and then that will give you the work done. So this is an experiment that you could do at home, but I don't think you have Newton meter at home. You could do this in school. There's a question of resolution. Resolution is something that is very important in instruments. You need to measure how accurate that instrument, the value that has been given is. So there's a way to do that. We'll cover that in subsequent lessons. Okay. So if you look on the screen, you see two forces. In fact, they are opposite forces. Okay. One is a thrust force, one is a frictional force. So they act opposite to each other. Now, what's the net force? Net force is basically when you compare the forces, which one is bigger than the other and how much is bigger. So here the net force is 0. Okay, the net force is 0, so it's going to move easily. Now look at this one. You have 15 newtons and you are going to do some work by pushing it. And when you push it, because the surface is rough, the work done, you need to work against the surface. There's a work that needs to be done to overcome the surface. So we call that work against friction. It's another video that we're going to cover that, but not in this one. Okay, but you need to be aware that sometimes you need to work in, there's something we call work against friction, especially when there's so much friction. You need to do some work to overcome the friction before the object will move. Okay, brilliant. Right, now we're going to talk about work done by moving something up or down. Okay, we said that when you do some work, this is moving up. Well done. Okay, so the work has been done, but this time, this is a special type of work which allows object to move up, or sometimes when it's up, it makes the object to move down. So when you do work where the object moves up, or when it's up, it moves down, then that type of work done is gravitational potential energy. I'm going to repeat myself again. If you do some work to make something move up, it gains gravity. It's working against gravity. So the force has been able to overcome the gravity. It's moving up. So the work that has been done is called gravitational potential energy. So GPE, or gravitational potential energy, is basically the work done to lift something up or down. Remember, the work done, we know that is force times distance. But when something is under gravity, we call that weight. We call that weight. So that is a special force. That's why I said GPE is a special form of work done. It's a special form of work done where the work that you do makes the object moves up or down. When it's moved up, you've gained GPE. When it moves down, you've lost GPE. So this object gained GPE. Why? Because it moved up. Okay, it gains GPE. It gained GPE. Why? Because the object had moved up because of a force. So it is a force that's making the object move up, displace upwards. If something falls from the top, then it's a loss. You are losing GPE. So it's a loss in GPE. Loss in GPE. Okay, it's a loss in GPE when something falls. Okay, so goes up, and this one is false. Okay, right. So we carry on now. So if work done is equal to force times distance, then we call GPE as a special type of work done. But now the force is under the influence of gravity, and any force under the influence of gravity is called weight. So GPE is equal to weight times distance. But here, the distance is upwards. Anytime something moves up, it gains height. If something moves up, it gains height. So instead of distance, we're going to write height instead of distance. They are the same thing, but a height is a special form of distance where the object moves upwards. Okay, it gains height. So basically, GPE is equal to weight. From key stage 3, you know that weight is force times gravity. So therefore, GPE is equal to force times, sorry, my bad. Weight is mass times gravity. Okay, don't forget that. Weight is mass times gravity. So therefore, you have mass times gravity representing weight, and then you have your height. So mass times gravity. And then the times the height, okay? So this is basically the simplest formula for GPE. Mass times gravity times height. So in simple terms, we can say GPE is equal to M for mass, G for gravity, and H for height. So the mg is the weight or the force. So that's why I'm telling you that GPE and work done, they are similar. So mg is the force, and then the h is the distance. So basically, GPE is a special form of work done. Okay, right. So I hope this is very clear. So we're gonna use that formula later on. Okay. So a woman lifts up a baby from the floor. So lift up. So when you lift something up, you are doing some work. Now, what type of special work are you doing? You are doing work that generates gravitational potential energy. Okay. So the baby weighs 100 newtons, and then the woman lifts the baby up 2 meters. What is work done? Very easy. The work done is the force times the distance. Okay. You know that. Very easy. So now, because the baby is moving up, we say the weight. So work done is equal to weight times distance, or force times distance. Because we are using weight, you cannot just say work done, because weight is a special force when something is under gravity. So we say GPE is equal to weight times the height. Okay, so you get 200 joules. So how much GPE? We are going to work out the GPE of a lifted object. So when you lift an object, it goes up. So once it goes up, the energy transferred is the energy stored in the form of GPE, because the energy is transferred due to the influence of a force. Okay. So this is an experiment. This is an investigation. You set up your rack, measure 5 different heights, find the mass of the ball, drop the ball down the slope, and time how long it takes. So this is a very simple experiment. You just have to get a ball, you set your track, you measure different heights, and then different heights will give you different gravitational potential energy. So this is your table. You record the data, the height drop. Let's assume that the height, hold on. Yes, let's assume that the height drop is 10. The mass of the ball is 10. So mass, to get the weight, you times it by gravity, which is 10 newtons basically. So the weight will be 100. Okay, because the gravity is 10, or 9.8 newtons per kilogram, but we normally use 10. Okay, Newton per kilogram. So the GPE is the height times the mass times the gravity. Okay, so 10 times 10 times 10 is 1,000, or you can do the height times the weight. The height times the weight is 10 times 100, that gives you 1,000. Okay, now the drop height is this one. The height reach is not, when you bounce, when something falls and bounces and moves up, it's not going to give you the same height at where it was dropped. So let's say this is 8 newtons. Okay, so which means that this at the end, at the start, this is the gravitational potential energy. After the first bounce, you get 8 times 10 times 10. So that will give you 800. joules. So you can create your own example. Remember that the gravity is always 10 newtons per kilogram, so the weight will be times 10 of the mass. You can change the height and you get different answers. Okay, so this is an investigation that you could do in school. I hope it's understood. Right, so work done is equal to energy transferred. So when you do some work and the work makes the object moves up, you are transferring energy in the form of GPE. Okay, so work done is equal to force times distance. We know that, and we know that GPE is equal to, here should be GPE because you are talking about weight. Okay, and GPE is a special type of energy that goes with weight. Anything that has weight, once it gains some height or distance is lifted, then you get GPE. So change in gravitational potential energy is equal to weight times the height gain. And we said from the previous slide that weight is mass times gravity times the height. So this is our formula for GPE, M times G times H, or weight times height. But GCSE, normally they're going to ask you MGH. They're not going to ask you to use the weight and the height. They'll always ask you to use the MGH. Okay. Right, we move on. So when you move something up and down, remember you gain or lose GPE. When you move something up and down, you gain or you lose GPE. Okay. Right, it's moving up, you gain GPE. Okay, so this is the formula that you should remember: mass times gravity or gravitational field strength times height. So we can put that in the formula triangle, and this is how it's going to be. And just do that to make things easier. So you have your GPE, and then you have your mass times gravity times height. So if you want to find the height, you circle the height, then you do GPE divided by mass times gravity. If you want to find the mass, you do mass, you cover the mass, you do GPE divided by gravity times height. It's very easy. Okay, so that is a formula triangle. So now let's look at some few questions. Okay, right. So this is the last slide. So remember, from what you have done, work done is force times distance. However, you could have a special type of work done when the object is lifted up against gravitational potential energy. When the object is moving from up to down, or is moving downwards, vertically downwards, it loses gravitational potential energy. And the work done to lift it up is the same as the energy transferred. And the work done to lift it up is what we call the GPE. The formula for GPE is mass times gravity times height, or weight times gravity times height. Sorry, weight times height is weight times height. If you're using weight, you don't have to talk about gravity. You do weight times height. If you're using mass, then you have the mass times the gravitational field strength, or the gravity times the height. Thank you. I hope you've understood the video. Okay.